ম্যাডাম এখন আমরা স্টার্ট করি। Good evening, madam. ম্যাডাম আপনি শুনতে পাচ্ছেন?
হ্যাঁ আমি শুনতে পাচ্ছি।
ওকে ম্যাম, স্টার্ট করব এখন?
হ্যাঁ এবার স্টার্ট করুন।
Okay, thank you. Good evening, everyone present here. We have gathered here for the third day of our lecture series organized by East Calcutta Girls College in collaboration with the Institute of Landscape, Ecology and Acoustics, India. I, on behalf of the organizing committee of East Calcutta Girls College, Department of Geography, would like to invite our Honorable Principal, Madam Dr. Mrs. Shukla Hajra, to say a few words to our participants.
Thank you, Anisha. I am very proud to welcome today's honorable speaker, Dr. Jyoti Shankar Bandyopadhyay, Professor in Vidyasagar University, and also I am pleased to welcome my colleagues and my students, all research scholars to this lecture series. The topic is very much interesting, that is disaster management and mitigation using web GIS. Actually, using web GIS, it is a paradigm shift in study of geography. We know that ICT in case of geography, that is the RSGIS, is playing a great role for the study of different problems on the earth. We know that Vidyasagar University, Department of Geography and Department of Remote Sensing plays an important role in the introduction of RSGIS, Remote Sensing and GIS, and Professor Bandyopadhyay, he is one of the senior most professor of that department. And today, all research are mainly man-centric or human-centric. And today, big challenges to all of us is to mitigate the disaster. We cannot stop hazard, we cannot stop disaster, but we can do our work on the processes, how we can mitigate these problems. So today's lecture on disaster management and mitigation using WebGIS plays an important part in our study, in our research, in the research of not only of geography, but also of different departments like environment. Under the umbrella of environment, we can say botany, zoology, anthropology. So this lecture enriches us and our students and scholars and enable us to do more and more research using this new technique, advanced part of geography. Thank you. And again, I welcome Professor Bandyopadhyay and all speakers and our teachers. And I hope that this will be very helpful for all of us. Thank you. Namaskar.
Thank you, madam, for your words of encouragement. We are honored to have this evening with us an eminent professor and researcher in the field of environment and disaster management and advanced cartography. Dr. Jyoti Shankar Bandyopadhyay is an associate professor and deputy director of the Department of Remote Sensing and Geographic Information System, Vidyasagar University, West Bengal. He has more than 18 years of teaching experience and was the former head of the same department. Dr. Bandyopadhyay has supervised more than 12 PhD scholars. He has been a guest faculty in both Ashutosh College and the postgraduation department of the Environment Science, Baligan Science College, both under the University of Calcutta. He himself was an alumni of the Department of Geology, University of Allahabad, and has done his PhD from Jawaharlal Nehru University, which was titled Integrated Coastal Zone Management under a Warming Climatic Scenario, a case study of the West Bengal coast. His research experience is even more illustrious, with 120 publications, including 70 international papers. He has completed 5 projects and has 3 ongoing projects, mainly based on the fishery resources funded by the Space Application Center, ISRO, and Indian National Center for Ocean Information Services, Ministry of Earth Sciences, Government of India. He is a life member and holds significant posts in the Indian Society of Remote Sensing, Indian National Cartographic Association, Indian Science Congress Association, among others. He is widely known for his contribution in the application of remote sensing and GIS in the domain of earth sciences. With this brief introduction, we welcome Sir to enlighten us with your valuable ideas, concepts, and experiences in WebGIS. Over to you, sir.
Thank you, Principal Madam, who is already known to me, and also Dr. Ananya regarding my introduction. Thank you for your introduction. I'm just trying to say something about disaster management as well as its web application, how we can do with this web, this management part. So please, my connection is very problematic now, internet connection. So sorry if I missed something. I'm trying to just show my slide. Okay. Just a minute. Yeah.
Yes, sir.
Is it visible to everybody?
Yes, sir.
Yes.
Oh. Okay. So just let us start with disaster management and mitigation using WebGIS. You know, we are all, at least in this part of India, we are facing a lot of disasters, which is, though the human casualty is less, but in case of material and properties, loss is very high. So just let's start with disaster management, what it means. It means the range of activities, not only at the time of disaster, but also prior to, during, and after the disaster, designed to maintain control over disaster and to provide a framework for helping at risk persons and their communities to avoid, minimize, or recover from the impact of the disaster. Disaster management activities are grouped into 4 phases that are related in time and function to all types of emergency and disaster, that is mitigation, preparedness, response, and recovery. So awareness and preparedness. Some critical questions that arise during awareness and preparedness for disaster management. It is basically, what is the population of the area? Location of the building and infrastructure, social and structural characteristics of the area, population at risk, evacuation time and technique, location of the safe structure that could be used as a shelter and others. In this point, you see, in case of Sundarban, what we have seen earlier, lot of human casualty. If we look the different disasters like our cyclone disaster, but nowadays evacuation technique and the safe structure is more than earlier one. So nowadays, this is a very important point in disaster awareness and preparedness, that is population of the area, location of the building and infrastructure, social and structural characteristics of the area, etc. Now, how the GIS and remote sensing plays some role here? To build database of critical facilities such as hospitals, ambulances, fire station, police station, school and other spaces which can be helpful for planning purposes. In case of cyclone prone area, the structure, that is the safe structure, as well as the different facilities which will be available for the people. Then another important thing is disaster map, which can be prepared to show the risk zone as well as disaster impact zone. From mitigation point of view, hazard maps can be created for various natural and man-made hazards such as flood, earthquake, cyclone, forest, etc., that help in understanding the risk of a location and planning accordingly. Now, uses of remote sensing and GIS technology in disaster management. You see, most of the disasters are spatial in nature. We don't bother about if lot of rainfall or cyclone is happening. Hello, am I audible? Is it?
Yes, sir,
Hello?
absolutely. Yes.
Oh, okay. Because sometimes my connection is just disrupting, so that's why I'm
No
asking.
issues. Sir, আরেকবার interrupt করবো. So could you click that button, hide, stop sharing এর পাশে?
আচ্ছা, আমি ওটাকে
Just hide the...
করতে। হ্যাঁ, sure.
Thank you,
ঠিক
sir.
আছে?
Absolutely, sir.
Okay. You see, we are not bothered about a disaster which is occurred in a deep sea without any big ship or anything. You know, most of the maximum rainfall occurs basically mid of the ocean, but nobody bothers because no human or any property loss. So we will be only consider the spatial nature of the disaster. So this GIS is basically act as a decision support tool. Decision making is possible by analyzing different GIS layers. Mainly here in this case, we use socioeconomic and geospatial data is mainly useful for management and planning of disaster, as well as tackling of disastrous conditions. Various departments and agencies who were stakeholders using GIS in the disaster management processes. GIS, remote sensing, and GPS. Is GPS or nowadays other GNSS, whatever it may be, you can call it, but is useful for disaster management application and for decision making. And you know, this computer evolution as well as availability of hardware is helpful for rapid expansion of GIS in both disaster research as well as practice and its management. GIS is useful for hazard zone mapping, and during emergency conditions, mitigation of people can easily possible using this map. GIS and RS much useful beneficial in mitigation strategies as well as in preparedness. Real-time geographic data can improve the allocation of resources for response. You know, nowadays you can take a picture from your mobile and send it to the authority or in the government to get the help. Nowadays, evacuation is very easy with this, but provided there should be the connection. That is the mobile network. Otherwise, but network is also now not that much bad like earlier days. GIS technology is much useful in modeling of disaster. This is a very important part. Modeling of risk. Which area will be affected? How the human will adapt the hazard? And it also, I already told you that it is a decision support tool. Disaster management system. It deals with mitigation, preparedness, response, and disaster recovery. All the steps are very important. Mitigation is the emergency, is the discipline of dealing with and avoiding risk. It is discipline that involves steps taken to contain or reduce the effects of an anticipated or already occurred disastrous event. Preparedness, that is how you prepare for the disaster. It is how we can change the behavior to limit the impact of disaster events on people. Just like if you ready for any cyclone, or if you don't go to the mid sea at the time of any big tsunamis or cyclones. So this preparedness can help you to get safe location at the time of disaster response. This is also an effective plan for public health as well as public human management and other personnel during the disaster, which outline the activities to design for the minimization of effects of catastrophe. This effort can be summarized as closely situation analysis as well as in response system, how your system will respond at the time of disaster. And another very important is disaster recovery time. This is the most important period because when the disaster happens, people will go there and give, give the sufferer some of the help. But when the disaster is over, gradually people, the help is fading away. So at the time of recovery phase, very much important in case of disaster. The aim of recovery phase is to restore the affected area to its previous state. So it is very important to get it back to the previous state. So recovery efforts are concerned with the issues and decisions that must be made after the immediate needs are addressed. So you see 4 pillars of disaster management: preparedness, then mitigation, response, and recovery. You see, this is a very famous picture. So GIS technology is utilized for preparedness as follows: site selection for adequate evacuation shelters with consideration of where and how extensively an emergency might occur. You see, nowadays, lot of flood shelters in Sundarban as well as our coastal area. This site is basically we use this site, and also location is using the GIS model, selecting and modeling evacuation route. Another very important part: consideration for time of day. Which time of the day this disaster occur? And at that time, it is a night time, then it is very difficult to evacuate. So you have to first you have to make the which way you have to evacuate the people. Consideration of the road capacity, how much people can be carried through the road versus the population, direction of travel, identification and mapping of key tactical and strategic facilities, that is hospitals, public safety facilities, suppliers to support response, that is flood, water equipment, building food, water equipment, building supplies, etc. Training and exercise to test preparedness, whether the people of that area is ready for the disaster. In Japan, you know, very frequent earthquake. So there is a mock earthquake recovery or mock, that type of mock training is useful for the disaster management of our area also. Model the incident. If you can model the incident, that is either plume, sprayed, or the cyclone, and collect damage assessment, identify casualties, and prioritize for allocation of public safety resources. Develop and distribute incident action plans, providing a key capabilities for the command and control of information systems that enable situational awareness and incident management support. GIS support the response mission as follows: provide warning and notification to the public, that is wide addressal system, others of pending, existing, or unfolding emergencies based on the location or areas to be impacted by the incident. Areas in which will be in harm way can be identified on the map, and mass notification can be performed from a GIS mode of view. Maintain shelter location, continuity of operation, supply, inventory, external power requirements, shelter of the population, capacities, etc. provide facilities for the assembly of department heads to collaborate, make decisions and develop priorities, provide the capability to create remote connections to the command center for official and others who need to participate but are unable to come to the command center. So remote system will be very useful. Establish the capability to share information and status with regional, state, and federal agencies. Support incident management operation and personnel. Provide required resources. Exchange internal and external information. Maintain incident status and progress. Facilitate damage assessment, collection, and analysis. Prepare maps, briefs, and status report for the executive leadership. GIS is integral for recovery by providing a central information repository for assessment of damage and losses that provides overall damage cost and priorities for the reconstruction effort based on appropriate local criteria. So which area is most damaged, whom will be get more help, location of the business and suppliers necessary to support reconstruction, assess overall critical infrastructure damage, and determine short-term action for the following, that is first aid and health, additional shelter needs, optimum location for public assistance, alternate locations for government operation if government facilities are damaged. Then alternate transportation routes for continued operation, monitoring progress by specific location of reconstruction efforts for both long-term and short-term needs, publishing maps to share information with the public and other government organization of progress towards recovery objectives. GIS basically optimizes the planning analysis, that is the mitigation process, as follows. Identifying and mapping natural and technological hazards. So first you have to identify which type of hazard it is. So natural hazards, this may include earthquake, storm surge, cyclone, flammable vegetation, areas prone to severe landslides as well as floods, and technological hazards, which include hazardous material location, transportation corridors where hazardous materials are routinely shipped, nuclear power plant, petroleum processing, and storage facilities. Now, I just want to share with you one famous incident. You all know the famous nuclear disaster at Fukushima Daiichi in Japan. The Daiichi, that nuclear power plant. So there was a famous saying of a famous scientist of Japan, Sanji Murai, Professor Sanji Murai. He said a very famous word that Japan thought that we solve every problem of our power. That is, we built a very big nuclear power station, but we don't think about the hazard part. We have done a big mistake that without considering the hazard of the nuclear power plant, it is not very wise to build a nuclear power plant. So we have to be careful about that. Then identify and mapping of critical values at risk. That how much population is this? You see, if there is a big cyclone in Rajasthan, very few people will die. But in case of Sundarban, population density is very high. So people will be affected more. Infrastructure will be more affected. That is, government facilities, hospital, utilities, public assembly, all will be affected. Natural resource concerns including scarce natural resources, plants, and animal habitat. Disaster management cycle proposed by Barnier 2006. If you see this cycle, first you look here, this is the pre-disaster phase. What you can do here, first you assess the risk, mitigation or prevention, preparedness. Then when the disaster occurs, you start warding as well as evacuating the people. then saving people, providing immediate assistance, assessing damage, ongoing assistance, continuous rigorous assistance is very important. Restoration of infrastructural services, very quick infrastructural services should be provided. Reconstruction, that is resettlement and relocation. Then economic and social recovery, ongoing development activities, risk assessment, that is mitigation prevention. As for the modeling of inland excess water coverage, WebGIS excavation can offer support in the mitigation phase of disaster management. A common view is that the disaster management is a continuous cycle of pre-disaster. So when disaster is not occurring, you should not stop. It is a continuous cycle of pre-disaster response as well as post-disaster phase. So I'm not going to in detail in what is GIS, we all know, but here I am very much interested with GIS services, that is OpenGIS. Wheeler and Mackey 1998, so we mainly use geodata service and geoprocessing services. Types of GIS, mainly we know that desktop GIS, web GIS, and mobile GIS. So nowadays, GIS is moving from desktop systems to distributed systems. That is OpenGIS concept. All are working in GIS platform and gradually converging to one space. Open Geospatial Consortium is a famous consortium. You can see I have given you the link of OpenGIS portal, develops specification to increase the interoperability of geospatial data and geoprocessing software components. WebGIS is a typical geographic information system distributed across a networked computer environment to integrate, disseminate, and communicate geographical information visually on the World Wide Web over the internet. So you see, it is a very distributed system. All are participants. It is a very participatory process. You can integrate, you can disseminate, as well as you can communicate immediately. Whatever happening in West Bengal, it is immediately go to the farther part of India, not only in India. If it can overpass the barrier of our country. From the US, you can see even your room. So you see, this is the concept of WebGIS. Disseminate geospatial data and processing tool, possible to process geo-related information with no location restriction. You see what I am telling you, that there is no location restriction. Everybody can be a geospecialist. Anywhere from the world, you can do your GIS. WebGIS architecture. What is the WebGIS? WebGIS, that is the client-server architecture, and another is the distributed architecture. Client-server architecture. How it is working? Geoprocessing, that is the server side and client side task. Typical three-tier architecture. One is presentation tier, another is application logic tier, and another is storage tier. So presentation tier is basically contains user interface, and application basically model and process GIS data, and storage tier is database that stores GIS data. You look at this client-server architecture. A typical client-server architecture, here the client is. This is the middleware. This is your web browser. So spatial request now through the internet is going HTML, image map, web server, internet map server, that is IMS. Now from GIS data and GIS software, this is the whole party server. Two types of client architecture. One is thin client architecture, other is thick client architecture. Client or server system that divides processing between client desktop as well as from the server. Client desktop basically requests data. Server only transmits the result of the request, not the entire file. So whatever they request, everything should not be sent to the client, only the request will be sent to the client. Client, web server with application server, map server, and data server. Distributed architecture. That is, here both data and processing components are distributed. All can use the data as well as processing. The client and server do not refer to a specific machine. Here, client is also can be a processor, and also server can be also a processor. We know server is the processor. So geo data anywhere, geo processing anywhere model. So this is the most important model of nowadays. You cannot control. So this is the beauty of this model. Nobody can control the system. There is a distributed object architecture, that is Microsoft Distributed Components Object Model, that is DCOM model, Common Object Request Broker Architecture. If you can see, the name also suggests broker architecture, Java Remote Method Invocation, Java RMI. Then here you can see when developing a web-based GIS application, the first step is usually to set up a web server that can handle incoming requests and generate corresponding responses. The most well-known open source map servers are GeoServer and Map Server. So this is web server. Through internet, client can call this PHP map server, database server, spatial data. Three types of architecture mainly used in this WebGIS: thin client, medium client, and thick client architecture. Thin client architecture, here user only needs to display map. So we are not interested to any kinds of processing or any kinds of modeling. Only we are interested on final map product. Medium client, here the user performs some data manipulation and analysis locally on their own computer in addition to map display. And finally, this is the most difficult part, that is the thick client architecture. Here, user perform advanced analysis of locality, advanced analysis locally in addition to map display and simple analysis. Here it is a very complicated way. The client can do the advanced analysis or personally in addition to map analysis and simple analysis. Thin client display requires a standard browser. Server requires map render, element generator out of its database application. Protocol, that is raster data transfer, uses mainly map display. Example, Google Map. Google Map is basically a thin client architecture, right? What you are seeing in Google Map, you are just asking Google that you show me this area. He is showing you this is the area, this is its location, that much. Nothing if you are interested. Then medium client. Here also, Google Earth is available. We can do few works in Google Earth, like display and map render requires a plugin in the web browser. Server, just like Google Engine, server element generator out of its application and database. Protocol encoded vector uses map display, data query, simple analysis, that is distance measurement as well as polygon. We all can do in Google Earth. This is a medium client. But in thick client architecture, we need some of the very high-end software like IGS, server, or other software is there. That is client display, map render, element generator requires plugins and standalone tools. So here is the difference. You need a standalone tool. Server allows for access to the application and its database. Protocol, basically raster and vector, uses display, data query, and advanced analysis, that is overlay, buffer, etc. Example, ArcGIS, and link is also there. Disaster management is done by following step in case of GIS. We also use the same thing, that is planning and analysis, situational analysis, or situational awareness, data management, and field operation. Planning and analysis. Here, the GIS is the most complete information system for modeling, analyzing spatial data, and displaying community vulnerability. When we identify hazard location with crucial infrastructure processed through GIS model can be useful for determining of event impact and necessary mitigation requirements. Preparedness is important when disaster event occurs. On analysis of risk and hazard is beneficial in emergency management and program. Situational awareness. At the time of situation, what we can do through GIS? Disaster and emergency management in situational awareness is essential thing. GIS technique plays a vital role to provide locational information of the event. Where is the event happened, what happened exactly in real time. Also by linking people, processes, spatial information, situational awareness established. GIS map interface important in handling emergency conditions. Data management team to achievement of preparedness, gathering of information, and its advanced data storing is important. In GIS, integration of information from other sources is possible. GIS solution is a standard-based, accurate cataloging of GIS data, provide useful information during emergency conditions. Field operations. This is very important part is disaster management. Field data is very important in GIS application. Field teams capture information in real time and send back to the user. So ground information useful for recognizing actual event condition. The new data can be sent to operation teams in field, so they have the information possible for protecting lives and providing safety to people, whether it's response or recovery phase. Mobile GIS provide right information. GIS include following information which is beneficial in disaster management, that is different satellite imagery like QuickBird, Spot, Iconos, and GIS data creation, preparation of base map of different themes using satellite imagery, thematic maps such as hydrogeomorphologic map, slope map, terrain map, and through this digital elevation model generation in GIS, it is useful for disaster planning. Macro and micro level maps used for identifying vulnerability and threat conditions, identification of safe location and zones for rehabilitation. Road and location map used for finding alternative routes, shelters and location, planning of evacuation and operation, management of rehabilitation, and post-disaster reconstruction. How the rehabilitation could be made, how the post-disaster reconstruction, whether it is useful to make construction there or not, suitable location identification, and scientific construction technology. No construction areas identified, so you have to identify the no construction area where people should not be allowed to make any construction. Rehabilitation of the existing people is very important. Hospital and medical facilities, identification for injured people. This is the flow chart of web processing services, WPS. You see GeoServer 3 2.2.2, that is WMS layer, that is user interface, AJAX request, Apache Tomcat server. That is, this is the GIS executes the model with the input. This all are the data which will be input here, and then it goes here. Finally, you can see the GeoServer will get this information, right? So system architecture for post-disaster management system. This is GIS database, attribute data, PHP interpreter, web user interface, web application, web browser user. This system will take the input from the users and continuously display the result and analysis to enable the management of decision making of the real situation. The system can be accessed by separate login for administrator and user. Multi-tier architecture, this is the client layer, this is the business layer. So first, this is the data layer. From data layer to application functionality layer. This is the business logic layer. And finally, the client layer. Those who are interested with the data. That is the disaster management data. You see different terminology is used. So these all are GIS support for emergency workflow. So this is the, you see, this is hospital, infrastructure, hazard, population, government building, transportation, utility. Now GIS plays a role in just dynamic data integration, sensor, AVL, weather, video, emergency call service. And in case of mitigation, risk and hazard analysis, vulnerability assessment, mitigation priority development, then contingency plan development, exercise, situational awareness. In case of response, mobilization of resources, activation of emergency control war room, incident management support, and recovery stage, assessing the damage, prioritizing recovery efforts, obtaining funds from the government or other sources, and monitoring the progress of the situation. GIS, this is a very schematic diagram which shows the how GIS helps in building a common operating environment. You see, there are many data sources. Finally, integrate and analyze this, turn into actionable intelligence. Here you collaborate, communicate, share to the world. So GIS architecture for disaster management. This is the ArcGIS software system. I'm not going to talk details regarding this. So example of how GIS provides accurate situational awareness through a common operating picture include maintaining and displaying the status of emergency and non-emergency events, designating and mapping incident location and perimeter. So which area is exactly the disaster happened? Site selection analysis for hot zone, incident command post ICP, additional evacuation sites, staging areas, different stage, how you shift the people, logistical support and supply caches, drop points, where you drop the people and the facilities, divisions and branch boundaries, and heliport. Nowadays, you can see, we all know the helicopter is also used for evacuation of people. So maintaining and displaying the status of public safety resources, both locally and in adjoining jurisdictions, modeling and displaying plumes, weather events, wildfire, flood, etc., analyzing consequences and losses, determining intersection that should be closed, that is based on incident perimeter, or plume and transportation route that avoid closure, importing and displaying damage assessment from mobile, displaying and printing appropriate incident command system, that is operational maps, logistic maps, tactical maps, air deployment maps, transportation maps, and incident prediction maps. You see, so all of the maps can be very real-time map, and it is only possible through GIS to make any real-time map. So it is one of the Minosta software, which how they use this map server work. You see, this is one just location of the server that web browser request map server result test.map file, right? So this is all at the different free desktop GIS software and application, which can be useful for this disaster web GIS. This is, I'm not going to take this detail. So this free web GIS software. World Health Organization also made one e-atlas of disaster risk for European region. It is an example of ScalGo Live global application. You see, this is the PDF map for disaster risk of European region, that is 2006. The different country places are shown here. This is the legend. This is the area where it could be sea level rise model. You see, as long this model makes, how they make it, if you can change this, it is not changing here, but if you can check this model, you can say, if you change this water level, gradually the area which will be inundated, you can get through this map. This Scalgo you can use for Digha area. This is elevation, flow accumulation, sea level rise, sink, etc. Detected activity for fire for a specific location, that is this area, it is shown here. Comparison of open source map server. It is some usefulness and some limitation of web server. Then WGRUS application architecture, that is map interface, that is manager interface, web server, geospatial server. This is the 5 metadatabase, file database. The WebGIS for risk assessment system was developed for visualizing risk data and performing risk analysis in the context of disaster management. This is the different WebGIS layer, WGIS list of available metadata for all resources. You can see this is the metadata for all resources, list of all available metadata, list of available retrieval of metadata for the specified WMS resources, retrieves metadata for the specified WGRS application interface. So you can see that is road, district, and elevation, how it could be affected. Layer categorization, different layer you can use for this disaster management. Request sequence for connecting to an open geospatial consortium compliant map services. So you see there is the, here you render, this is the client, validation, existing URL, it is external OGC service, this is return map image, get map, extended version and first XML, return capabilities, XML, get capabilities, result from requesting an external OGS compliant services. So you can use a form for result. First 48 hours result, fires of first 24 hours, NASA firm WMS services. You can use the NASA tool also. That is Armenian DEM is a DEM. It is used here. Extracted polygon based on user inputs to the flooding tool. That is user input. You can give different input and get the flooding area. Buffer operation performed on polygon, which area you should cover through this buffer distance, 1,000 meter buffer distance, and how much area will be affected by flood. Query by attribute tool, that is which area, this is the different location, and this attribute tool can be used for where the hospital is located and how the people can be evacuated and sent to this hospital area. Then point in polygon from layer you can use. Nearest object tool, which is the nearest location, you can use through this nearest object tool. Tools for measuring distance. Make sure that but in case of measuring distance, you have to make sure that the map layer is activated by checking the checkbox in active column in map data panel, then click the target. And now I'm showing you just one small development of WebGIS server using open source software. You all, those who are the research scholar or the student are attending my lecture, you can very simply doing this exercise. First, installation of PostGRE SQL. You see URL for download of PostGRE SQL is, this link is shown here. You see, you can first make your password and your password and your registration part. If you can over, then port you can just select, then change to the next. Then installation of PostGIS extension using Stack Builder 4.20. It is open source. It is freely available. You can check and do this. Now you can do this operation, that is you stack building. Then this is the spatial extension you should include, and then next you just pop this menu and just click it. Then you just write down one small SQL. This is just I prepared this type of SQL you write, and finally load zip file into the web browser. You make a zip file of that area, and just web browser you can just load this zip file, and you get this information in case of this is the admin side, and this is the WebGIS server monitoring using, you may be the admin or you may be the client using. Admin can see how much people are using, which area is covered. You see how much people are using transaction. This is rollbacks. This is how many people this kind. This is your dashboard where you can see which area and how many people are using. And in case of client side, you can choose different information that your name, host, this way you can use this. And WebGIS server using a client, you see here, this is our part of just Purulia Bankura area where PostGIS classification. And here you see one animation is there where a flood is just moving on due to the climate change. You can see this is flooding. This is one animation. You just look this image. And this is the animation using that software. And yes, it is over. So thank you all.
Thank you, sir. Thank you for this wonderful, yes, sir. So thank you for this wonderful lecture. I hope our scholars, especially the scholars, for the students, yes, we have done some form of GIS with the undergraduates, but postgraduates, they know, and for the scholars, it will really be helpful. We could probably extend this lecture and for an advanced version next time. So thank you for delivering the basics of WebGIS. If I would request our participants, if they have any queries or questions they would like to place, they would ask, sir, they can. Any questions?
Yes. So thank you. Just important thing, I have already just presented my lecture, and I have shown the different HTTP connection where you can get this free software, OpenGIS software, which would be useful for the students for prepare any disaster management map. So you can try with that open source software. Students can try. Thank you all for your patience. So just I am finishing my lecture here. If any question, I can answer, but otherwise, Madam Haldar, if anything,
yes.
Then thank you all.
Thank you, sir. We would invite our head of the department, Dr. Panchali Mojumdar, to
Yes.
give the vote of thanks.
Yes, sir. Thank you so much for such an enlightening lecture, particularly for our students, research scholars, and all. Thank you, sir. Hope we will be connected in future also, so that our students can learn more from you. And sir, it's a privilege for our department, on behalf of Department of Geography, East Calcutta Girls College. I would like to thank you for delivering such a beautiful lecture, such an insightful lecture that is very helpful for all of us, particularly when there is the global trend is for GIS remote sensing, and we have to proceed in that way. Thank you, sir. Thanks a lot.
Thank you. Thank you.
Principal, madam is here. Madam?
Yes,
ma'am, please.
Yes, of course. I must thank Professor Bandyopadhyay, and I I may suggest our students I have seen that they write for the link. Yes, you will get link from madam and as a department. And also the most important thing is open source software. There are two things. I hope you you can get an idea that you will have to make a list for preparedness. And last years, for years, National Disaster Management Team they came and they needed some information like the road map, the location of the school, to keep the rescued persons. So you need to make a list of preparedness, which Professor Bandyopadhyay mentioned, and then you will make a map and you put the data for making a web map which can be used at the time of a disaster. So disaster management, web GIS is most important, because if it is in web, someone may get the information that where can people will go, how can the food and other necessary things will be provided to the disaster affected people, hazard affected people. So you have to make two things. You have to know the cause of the disaster, and you have to know the preparedness of the disaster, and then you put the web, put it for preparing web GIS. So link are there. There are many links. Professor Bandyopadhyay provided that, and I thank Professor Bandyopadhyay, and I hope students may do this work in future using WebGIS. Thank you.
Thank you, madam, just for a nice word. I'm really delighted to be with your college. I'm from the very beginning. I know Dr. Hajra. She's also just like my teacher also, I can admit, because from the very beginning we are with INCA. She was a very good mentor of INCA. We all know, and we have lot of his student, most probably Devdeep, when he was a student, we all enjoyed his presentation in INCA. So madam must remember that beautiful time we've spent in the different INCA conferences. So thank you, madam, for giving me the opportunity to hear with your students and scholars. Thank you, madam. This is my privilege to be with your college.
And you are my colleague, and also you will be very happy if now the students try to do this because today they will get open source. So
exactly, madam. I have lot of link I have shared.
Part that they can use this, and they can understand that how can it will be done by them.
Yes, exactly, madam. They can themselves be the WebGIS expert. I have shown one, just giving the link. It is very difficult to within 1 hour. That is the another 1 hour part, that software making. So they can also prepare the software also. That OpenGIS, what I have last part of the lecture.
If you provide a workshop training on preparing WebGIS, so they can prepare at least on Lake Town, the urban plat, or in the other part of different parts of North 24 Parganas, Calcutta. So if you provide
it can be done, madam, but
training,
exactly, madam, but that this COVID situation should change, madam, because it needs the human touch, madam. This online thing I don't like. Please don't mind this, but I'm not happy with this. I'm not that much conversant enough to be. I'm very much conversant with board and direct contact with the student. So I'm not preferring this. It's very difficult.
Is it possible to provide the training for online for WebGIS, because these are all software based?
Exactly. It is possible, madam. But yes, it is possible. We will plan for this. Sometime we will plan.
Yes,
madam.
thank
It
you.
is
Thank you
possible.
very much.
Thank you, madam.
Thank you.
Thank you so much, madam. Thank you, sir. We end our session today here. Thank you.
Thank you all.
Yes.